right? I'll give you examples on what we, some of the things that I already said last time about standard deviation and the more special standard deviation variance. So an example is this one as an example one. Cartons of orange juice are advertised as containing 1 liter. A random sample of 100 cartons gave the following results. For the volume X. And then have this one. The sum of X is 101.4, and sum of X squared is equal to, this is 102.83. 102.83. Then the question is calculate the mean and standard deviation. So the question is calculate the mean and standard deviation of orange juice in the 100 cartons. Of orange juice in the 100 cartons. Right? If you look at what I told you, it's better if you know that this is the sum of X and this is the sum of X squared. And they want to calculate the and that, and take note that there were 100 cartons, and this is your A. A is 100, so you have got 100 cartons. There are 100 cartons there. Then to find me, don't find me, remember, to find me, that is what it is to say sum of X divided by A. That's the mean. So this is video mean, right? And your sum of X there is what? This one, 101.4 divided by your A is what? 100, and what you are getting there is what? It's the mean. Therefore, the mean is equal to, what's the mean? 1.014. That's your mean. You divide by that one, gives you that. 1.014. That's the mean. This here, you have calculated the mean. That's the mean. Then the second issue is to calculate the standard deviation. The second issue is to calculate the standard deviation. Now let's calculate the standard deviation. Remember that I gave you two methods of calculating standard deviation. There was the first one which I actually said is a very difficult one, and the second one is the one that is very bit. So to calculate standard deviation, to calculate as number B, this one, calculate standard deviation. What you do is we are saying sum of X, sum of X squared divided by sum of X squared. Calculating what do we say? That is sum of X squared divided by Rn, right? Divided by n minus x bar squared. But now, this one, what we are getting here is variance, right? Well, this one we are getting here is this. It's the variance. So you square root that one. So to find this one, you square root that. Square root this one. That. So if you look at this one, this it is that, which is that 102.83 divided by 100 minus x bar squared is this one 1.014 squared. Answer you square root that one. What you are getting there? It is your this. What you are getting? That. So if you look at that, this divided by that one gives you 1.0283 minus 1.014 squared. That one you do that. And into this one, what is 1.014 squared? One point 0.028 like that. Like that. What is it? Huh? That one? You're getting this? Subtract that. Subtract this one. 0. Subtract that. What is matter? Subtract 1.0283 minus 1.028. 0.0003. Alright? But there is this one. Now, to find your standard deviation, you are square rooting that 0.0003. Do that. So your standard deviation is what? 0. Okay. So this is 0.01 what? 7. Alright? This is standard deviation. It means you have calculated this and have calculated. Calculating simple. Just take this by n. N is number of masses 100. Simple. But now to calculate standard deviation is where now we are using standard deviation. Now we are using this one and that, and then we square that one, then it ends up to the last. That's how you get the standard deviation. Right? So the standard deviation of the volume is 0.01 or something like that. 0.01 or whatsoever you are going to do. Right. This is example number 1. Example number 2. Example number 2. A machine. Let's go to example number 2. You have questions, you don't know what? Good. Example number 2. A machine is supposed to cut lengths of road. A machine is supposed to cut length of road 50 centimeters long. A sample of 20 rods. A sample of 20 rods. A sample of 20 rods gave the following results for the length x. The sample of 20 rods gave the following results for the length x. So, there is what they're saying is sum of fx is equal to 997. Sum of fx squared is equal to 49.711. Calculate the mean length of 20 rods. Calculate the mean length of 20 rods. B. Calculate the variance of the length of the 20 rods. Calculate the variance of the length of 20 rods. So there, if you look at what they have asked there is this one they are saying a machine is supposed to cut length of 50 centimeters length, no? A sample of 20 rods give the following results. That calculate the length of the 20 rods, calculate the machine, calculate the variance of the length of the 20 rods, state the units of variance in your answer. Alright? This is the information. The sum of f of x. Remember, this is the one that for you to find mean given this frequency distribution, mean is equal to sum of fx divided by sum of what? That's the mean. Right? And find variance. That's what we actually said. Sum of fx squared divided by sum of f minus x bar squared. And to find the standard deviation, sum of fx squared over sum of f minus x bar squared, something like this. Remember that? Still remember that? Is that? Huh? Okay. Then let's work out. Let's start working out now. To find mean, given that one, mean sum of fx divided by sum of f, which is your alpha is this one, 997 divided by sum of your frequency. What's your frequency there? You look at the question, what's your frequency? What is your frequency? 997 is your sum of fx, but only f only. So they're saying a machine is supposed to cut length of road 50 centimeters long. A sum of 20 rods, there were 20 rods together, right? There were 20 in total. It means your f is 20, right? Therefore, your f is what here? It's 20 here. So you want to find the mean here. So how do you calculate mean? How do you calculate mean here? Do it. Do it. How do you calculate mean? Yes, it was what? 49.1. Very good. So this is 49.85. 49.85, and that is your mean. Now, if your mean is that, it's easy for you to find your standard deviation or your variance. Let's calculate variance here. Calculate variance. Sum of f x, if you look at that one, it is this one, which is 49.711 divided by sum of f. Because if you look at this one from this one, sum of f is equal to 20 here. So here it is 20 minus x bar, which is 49.85 squared. Variance will be that. If you work it out, 49.711 divided by 20 minus that square, of which when you work it well, it has to give you 0.5275. 5275. This is the variance. That's a variance. Next, finding standard deviation. We are looking at 0.5275, and you can get the answer in cubic centimeters. You can find your standard deviation. This is the variance, right? Yeah. So if you are to find standard deviation, what you are doing is you can square root You have to square root your variance. The way you square root the variance, what you are getting now is the standard deviation. So standard deviation, you are square rooting the variance. Is it fine? We are proceeding. Right? The second element that we are looking at now is about cumulative frequency, which is CF. We are looking at cumulative frequency, and that is our CF. Before I come to cumulative frequency, or you verify whether that is correct, and then we can go to the other side, which is the cumulative frequency, which is the same. We are looking at now cumulative frequency, which is the CF. For the cumulative frequency, which is the CF, it is again taking us from the present data that we have been looking at. But now, this table, the cumulative frequency, the way the cumulative frequency is more or less like from the original data that you have, it has to be accumulated, it has to be accumulated as you go along. It has to be accumulated until you reach the last data. That's why we call that as the cumulative frequency. Therefore, I will explain how do we come up with the cumulative frequency of the discrete data, and how we come up with the cumulative frequency of a continuous data. For discrete data, as I actually say, that is just data that has got values and the real values. It's quite different from continuous data. Continuous data, it is the data that is grouped, where you have got a group. That's what is called continuous. Therefore, we look at these two in terms of cumulative frequency, the CA. Hence, we are coming up with cumulative frequency. Cumulative frequency, which is called the CF. Right? The cumulative frequency you are right. The cumulative frequency is the total frequency up to a particular item. It is the total frequency up to a particular item. That's why I was saying that you have to accumulate, it has to be accumulated up to the last item. A cumulative frequency distribution, a cumulative frequency distribution can be obtained from can be obtained from a frequency distribution, and can be illustrated in two. You can illustrate it in two. One, I can illustrate the frequency distribution in two. One, when the data are discrete or are grouped, you use what is called in the Excel diagram. If it is a graph now, when the data is discrete or ungrouped, like 1, 2, 3 up to the end, you use the Excel diagram. You use step diagram. But when the data are continuous, or they are in the form of grouped, the first one is an grouped data where I have discrete parts. When they are grouped, when the items are continuous or in the form of grouped discrete distribution, you draw you use that one by drawing a cumulative frequency polygon or a K. So what you come up with is what's called cumulative frequency polygon or a K. So you use what's called, you draw a frequency, a cumulative frequency polygon, or sometimes known as a K. A frequency is what's called a cumulative frequency polygon. Cumulative frequency polygon, or sometimes known as a K. So in other books, they give they give it as an OR give. OR give is the same, an OR give. Sometimes it's known as an OR give. It's called an OR give. The word OR give, a K frequency polygon is the same. It's the same. So we'll be looking at this too. We'll come up with how do we draw a frequency distribution table, and how do we draw this, the OR give, and then how do we draw the step diagram. We'll start with the first one. In other words, if you are given, in an example, if you are given data that is discrete, you use what's called the step diagram. But if you are using what is called grouped data, if it is grouped data, that's what you use. You use what is called the polygon, this polygon or the OR. Now, let's start with that. I'll give you an example, and an example is this one. Yeah. Where cumulative frequency step diagram for this data. Cumulative frequency step diagram as a cumulative frequency step diagram for discrete and grouped data. An example is that one that the table shows the number of attempts. The table shows the number of attempts needed to pass the driving test by 100 candidates at a particular test center. The table shows the number of attempts needed to pass the driving test by 100 candidates at a particular center, test center. So I've got one number of attempts. Those who attempted once, there were 35 of them. In other words, one, there were 35. Those who attempted once. Those who attempted it 2 times, there were 42 of them. 2 out of 42. Huh? Oh, the first one is 33. The first is 33. The second is 42. Right? Yes? Those who attempted 3 times, they were 13. Those who attempted 4 times, they were 5, 6. And those who attempted 5 times, they were 4. Those who attempted 6 times, they were 2. They were 2. Then the question is, present that information in a cumulative frequency distribution. You formulate that in what is called a cumulative distribution, frequency distribution. Now, if you have to present that information, you look at that information which is there. If you look at that information, you can present that one in a cumulative frequency distribution, this information. Where, when you are presenting it, you are presenting it like this. Look at that. It is something to do with this. We have got number of attempts. Look at that one. We have got number of attempts. Number of attempts. And we have cumulative frequency. CF. Cumulative frequency for the first one. For the first one, which is the less of equal 1. 1. The second, let's do the 2, equal to 2. The third, let's do the 3. The fourth, the 4. The last one, let's do the 5. Like this. For the first attempt, that was the 3. Then the 3. If you go to the second attempt, it is 42. Now, for the second attempt here, it is 42 from that one plus 33 plus 42. 33 plus 42. And what gives you 75. For the other one here, it's going to be 75 plus, on top of this what? 30. 75 plus 30, which is 88. 88. For the other one, it is 88 plus 6. 88 plus 6, which is 94. For the other one, it is 94 plus 4. 94 plus 4 is 98. The other one, 98 plus 2, which is what? 100. That's what 100. In other words, what they are doing there, they are doing something like this. Now this. Very frequency here. Here you have your number, your X here, 33, 75, 33, after 33, what is that? 33, 42, after 42, what is it? Yeah? 13, after 13, 6, after 6, 4, after 4, 2. Let's take it together. Now, if you look at that, what is your, what is that? The what? X minus? Now this one is not the, it's you are now one frequency. You see, forget about X minus. Those things is gone. Yeah, those things this is another topic, cumulative frequency. Those ones are gone. But now if you look at this one, it is cumulative frequency. Cumulative frequency. X cumulative frequency. Right? The first one, this is they want to come up with this table here. And a short way of coming up with that table. That table here that we have brought here is this one. I want you to see what it is. 33. For the first one is 33, no problem. To come up with the second here, for this one, you take this plus that. Take that plus that. 33 plus 42. 70 what? 75. And this is 5 in this one. To come up with the here, you take this plus that. And this plus this one, 8 what? 8. And this one is this one. To come up here, you take this plus that. 90 what? 94. To come up with this one, you take this plus this one. 90 what? 98. To come up with this one, take 98 plus this one, and it gives you what? 100. And this is exactly what we have prepared today. Or another way. This is 33. 33. To come up, this is 33. For this one, it is you take this plus that to go there. So it is 33 plus 42. Then the answer is this. Take this plus that, you see this. Right? Sorry. To come up with this plus that, there. This plus there. This plus this plus this plus this. This plus this plus that plus that plus that. That plus this plus that plus that plus that plus that gives you 100. You get it? At first it is this plus that, this. Right? This, that. This. You are adding this. You are adding. That's why I was saying this. Take this plus that, this plus this, that's the same. The way you have, if you look at this one, the way it is big, you are arranging it from 33, 75, 88. You are going in ascending or you're going up. You say this is 33, 75, 88. It goes up. How you say that? Yeah, that is the way you do it like this one. If you go to this one, it is 33 plus 42 plus 13. If you go to this one, 33 plus 42 plus 13 plus 6. If you go to this one, 33 plus 42 plus 13 plus 6 plus 4. Then this one, 33 plus 42 plus 13 plus 6 plus 4 plus 2. You are getting the last one, 100. So how you do it? Simple. 33, 33. This, that, this. This plus this gives you this. This plus that gives you. This plus this gives you. This plus this gives you. Or this, that. To find this one, take this plus this gives you. Find this one. Find this one. Find this one. You are just this accumulation now. This one. That's what we call this one. This is what is called cumulative frequency. Now, if you look at if it is to draw a cumulative frequency graph, you will notice that there is 33, 75, 88, 94, 98, 100, 100. If you look at the graph, it's going to go like this. If you look at this graph here, what is happening to that graph? 100 is here, the top. Because 100 will be here. 50 will be here. 0 will be here. Right? So look like that. We'll come up to that. Now, but if you look at this one, because this is what is called, this is discrete. We don't use this graph. We use what is called a state diagram. Because this is discrete. Now, let me draw a state diagram before I come to, because state diagram, if you look at this, because state diagram here is for discrete. For discrete data. Use that. But in this one, it is for continuous. Continuous data, you use what is called frequency polygon or orthogonal. Now, this one here, what we are coming up here, this is a discrete. Therefore, if we are to draw a graph of this discrete, we are using state diagram. We are using this one. Now, let's draw a state diagram here using our graph. Let's draw a state diagram. We are getting state diagram of this information here. Let's draw the state diagram. State diagram is going to be like this. Our graph, if it is to draw a graph, it's going to be something like this. CF, cumulative frequency. Always CF is here. Cumulative frequency must be here. Over number of attempts. Here. Cumulative frequency, CF. Number of attempts. Now, here, this is number of attempts here. Number of attempts is our x, which is our x here. So, cumulative frequency is this one. 0, 20, 40, 60, 8, 100. Number of attempts is this one. Number of attempts are those ones where we are going to number of attempts. We have 1, 2. No, these are the number of attempts. These are just the data we are giving. Number of attempts 1, 2. Those are just the frequency of candidates. These are just frequency of candidates. Frequency of candidates. Number of attempts here. Number of attempts here. 1, 2, 3, 4, 5, 6. Those are number of attempts. Now, if you look at this one, number of attempts here, you are going to have 1, 2, 3, 4, 5, 6. Number of attempts. Right? Number of attempts. Right? This is our frequency. Very frequency. Number of attempts. So here 33 is our frequency. 42, 30, 6, 4, 2. Those are the frequency of candidate, but the number of attempts are these ones. Where the frequency is number of attempts, frequency, frequency. So cumulative frequency is going to be effect. Now if you have to draw a diagram, 1 is 33. One is corresponding to 33, which is here. 1, 30, 33 is also 30, 33 is also 1. 2, 75. 2. Look at what we are doing. 75. 75. 2. 75. 75. Let's assume 3. 88. 3. 80, 90, this will be 88, 3, 88, 3, 88. Four, 94. 94, let's see. 5, 98, 98, 5, 6, 100, 100 is good. Step diagram, what do? You take a ruler, step diagram, two, 3, 4, 5. here. This one you have drawn here is what's called instead what? Instead diagram. From there,